Hello students. So today we're actually looking at making compounds. But before we begin, it is very important for you to make sure you've got all your equipment with you. So I would like you to pause the video, go check around, make sure you've got your pen, you've got your pencil, you've got your ruler, you've got your green pen, you've got your book, and then when you're ready, play the video. Alright, welcome back. Now, like I said, today we're actually looking at making compounds. And our learning objective is to know how compounds are different, okay, to elements when they are formed from them. Now, what I want you to do is to actually pause the video again, and I want you to write down your learning objective. When you're ready, press play. Okay, now what I want you to do, okay, is to match the statement to whether it's a compound, it's a mixture, or an element. So, is A compound? Is B a mixture? Or is C an element? Again, I want you to take your time. Of course, I know you haven't got any worksheet, but you can still write it down in your book, whether A is a compound, a mixture, or a mixture, or a compound. So I'm going to give you just 2 minutes to actually do that. When you're ready, again, press play. Okay, let's go through the answers. Again, grab your green pen. From what we can see for A, we can see that there's only one type of atom. So this is actually an element, okay? When we look at B, actually, let me just tell you about A. A is actually nitrogen, in case you do not know if you look at your periodic table. Now, when we look at B, we can see we've got hydrogen, we've got chlorine, and we've got carbon dioxide. It's got 1 atom of carbon and 2 atoms of oxygen. And is this a mixture or is it a compound? Well, I would like to tell you this is actually a mixture. We can see there are different types of compounds there, but they are not chemically bonded together, so it's a mixture. All right, when we look at C, we can see that these two are actually chemically bonded. We've got sodium and we've got chlorine, which give us sodium chloride. You're going to learn that in a bit. So this is actually a compound because they are chemically bonded together. Again, pause the video, mark your work, and make your corrections. When you're ready, press play. All right, let's continue. Now, what I want you to do now is to actually write down these 4 keywords: element, compound, molecule, and mixture. And I want you to write next to it, okay, the right definition. Again, I'm going to give you around 3 to 4 minutes to actually write this down. When you're done, again, press play to continue. All right. So the first one says element. What is an element? What is the definition of an element? Well, elements are basically made up of just one type of atom. If you got it right, give yourself a mark. And the next question is asking you, what is a compound? Well, a compound are basically 2 or more different elements that are chemically joined together and not easily separated. Again, if you got it right, give yourself a tick. And the next question is asking you, what is a molecule? A molecules are basically 2 or more atoms joined together, and they can either be the same element or different elements as well. So a molecule can literally be a compound or an element, if that makes sense, but it has to have 2 or more atoms. All right, the next question is asking you, what is a mixture? And I'm sure from what you can see, these are molecules of elements or compounds that can be physically separated but are not chemically bonded together. Okay, again, if you got full marks, give yourself a mark. If you didn't get full marks, make sure you use a green pen to correct your mistakes. All right, let's move on. Now, this is our success criteria today. Hopefully, we'll be able to develop our knowledge. We should be able to make a new compound virtually and identify why this is a compound. Obviously, if you're in school and if there was no restriction, we should be able to do practical, but obviously this is a virtual learning and this is a chance for you to actually make some observations and make some notes. Hopefully, we should also be able to secure our knowledge and be able to understand that when the compound is made, new products are formed. This is something you need to get into your head as well. And hopefully at the end, we should be able to master this knowledge as well. These are our keywords, which are chemical change, element, compounds, and mixture. Again, I need you to pause the video and write down these keywords. And when you're ready, press play. All right, let's move on. Now, making a compound. Some elements, when mixed, will react together, and that is the truth. And the atoms become chemically bonded, and these are called compounds, like we learned in the last lesson. Okay? Some elements, when you mix them together, they actually react and they form compounds, if I'm making sense, because they become chemically bonded together. Of course, I'm sure you're going to be asking, why are they chemically bonded together? And this is something you're going to be learning as you progress in your academics. Now, we're going to pretend like we're going to actually be making a compound. Let's say we're going to be making magnesium oxide today. Now, what we need to do is we'll see what we need to make it and how we're going to make it. Now, I'm going to be talking to you about a few rules you need to know about working in the lab. Technically, these are some of the things you're going to need if you're going to be performing the experiment. You're going to need a mat, you're going to need a Bunsen burner, a magnesium ribbon, and a tongue, okay? Now, for safety, it is so important for you not to look directly at the flame when the magnesium burns, okay? It is very bright and could hurt your eyes, okay? Now, these are some rules as well. It is so important to make sure your bags and stool are under the table. It is so important that one person gets a heat-proof and mat and a Bunsen burner. Also important to get safety glasses and magnesium ribbon. And it's so important for you to know that you're responsible for putting away the items you've collected. Now, again, these are the rules you need to know when performing an experiment. Again, the reason why we're doing this is for safety reasons, to avoid injuries, okay? If that makes sense, and your safety. All right, moving on. Now, whenever you perform this experiment, okay, we're trying to carry out this reaction. These are some of the things you're going to observe. There's a chance that they'll ask you to actually draw a table to write down your observation at the start of the experiment. What can you see? What state of matter can you see? And also, during the experiment, are there some changes you're seeing? And at the end of the experiment, what are things you're seeing? Now, these are some of the keywords you might be able to observe in your experiment. Sometimes you can observe a bright light, you can see a mixture, you can see something that is dull, element, a fizz as well. You can see a chance of a compound and a change of color. Again, these are some of the observations you're likely to see when performing an experiment. Okay, so let's have a look at this. Now, let's say we're actually performing this experiment of making magnesium oxide. What happens now is the fact that you use your tongue to actually take the magnesium ribbon and put it under the Bunsen burner. And what you're going to see is a bright light actually burning away the magnesium ribbon. What's actually happening is that magnesium oxide is forming because the oxygen in the air is reacting with the magnesium. And this actually forms magnesium oxide, which is something you see down there. And then a compound is formed. If I'm making sense. Now I've just given you a brief summary of how the experiment is being performed. What I'd like you to do is actually to pause the video and attempt to answer the questions. Again, when you're done, click on play to continue. All right, let's continue. So the question says, how can we tell that magnesium and oxygen are elements? The first answer is that the atoms are the same, e.g., magnesium, all purple, circle, if I'm making sense. So we know that the atoms are actually the same. You can see that magnesium has got a blue color and the oxygen has got a pink color. That is how we determine whether it's an element or not. So there's only one type of atom present. The second question says, how can we tell that magnesium oxide is a compound? Well, what we can see now from the image, from the illustration, is there's actually a mix of color there. You can see a purple color and a pink color stuck together, chemically bonded together. Okay? Now, the third question is asking you, do you think it would be easy to separate the magnesium and oxygen atom once they have formed a compound? And explain your answer. Well, the answer is actually no. It's difficult because they are chemically bonded together. And for your extension questions, how do you know a chemical reaction has taken place? and I believe you should be able to say this, okay, is the fact that new product is formed and you can see a bright white flame, okay, from the picture there. So again, if you got everything right, give yourself a mark and write down your final score. If you didn't get everything right, make sure you use a green pen to correct your mistake. Again, you can pause the video and do this, and then press play to continue. Okay, let's move on. Now, what we'll be able to do is actually to develop our knowledge in this. Now we will try to secure our knowledge. Let's do a true or false question. Now, we started with 2 elements. True or false? That's true. We have given you away the answer. The product was easy to physically separate. Is that true or false? The magnesium oxide? True or false? Well, it's false. Okay, compounds are not easily separated. Now, the product was a mixture. Is that true or false? Well, that's a false. It's a compound. Number 4, magnesium and oxygen are chemically bonded together in the product magnesium oxide. True or false? True. And the last one, there was a new product formed that had different properties from the properties of the reaction element. True or false? True. Again, give yourself a mark if you got it right. If you haven't, use your green pen to correct your mistakes. All right, let's look at these checkpoint questions, okay? Now, what elements were the reactants? So basically, what elements did you start with? That's what reactants are. The second question is asking, what was the name of the product? What basically did you make at the end? And the last question says you should complete the diagram to show how particles change in this reaction. And again, the last question says, did you make an element, compound, or mixture? And how did you know? Again, I want you to pause the video. Okay, I'll give us about 6-7 minutes to answer the questions. And when we're ready, we press play to mark our work. All right, let's continue. Now, first question, okay? This is actually magnesium and oxygen, which was our reactant. This is what we started with. And what we ended with was what we call a magnesium oxide. And if you look at number 3 diagram, you can see that the elements are now chemically bonded together using the lines to represent it. And number 4 is actually a compound. The compound was formed. A new substance was formed that wasn't easy to physically separate, so that it was chemically bonded together. Again, give yourself a mark if you got it right. If you haven't, make sure you correct your mistakes using a green pen. All right, now we've been able to actually secure this knowledge. Now, making iron sulfide. Now, to make iron sulfide, you require iron and sulfur. And when they react together, they chemically bond together and they form what we call iron sulfide. Now, chemical change. A chemical change is where substances combine to make new substances. There are 2 different elements, 2 different atoms coming together to make substances. Okay? And you can easily watch a lot of videos. An example is actually a firework. Okay, you could see firework. These are actually reaction taking place between 2 different elements, if I'm making sense, or different atoms. And actually burning a wood is actually an example as well, because new properties are made. Making a cake as well is a typical example, and making egg, a fried egg, is actually an example. Now, let's have a look at these questions again. Okay, checkpoint 2. I want you to pause the video and I want you to answer the question. All right, let's have a look. What we've done is actually to make, now virtually made iron sulfide. Again, our reactant is actually iron and sulfur, and our product is iron and sulfide. And again, we can see that they are now chemically bonded together using the picture to illustrate it. And number 4, again, a compound has been made. It is chemically bonded and you cannot easily physically separate them. You require a lot of energy to do that. So the question is, what happened at the end of our experiment? Did we make iron oxide? Okay. Now, this is exactly what pretty much happened. A new product was formed, which was a compound which was easy to physically separate. A mixture was formed, which was easy to separate. So which one is actually our answer? Now, the answer is actually 3. Okay. Because the answer is actually a new product was formed, which was a compound, and it was not easily separated physically, if I'm making sense. Okay. Now, what we'll be able to do is actually to cover all of this. I hope you've learned a lot from it. Again, if you've got questions, email our teachers, and we're going to be sending you or giving you some achievement points and answering your questions. And I'll catch you on the next topic. See you later.